So what we have here is a Murphy CBH1500 base station. So these usually hum. We're going to do the power supply to try and lessen that. I'll just check that the plug's got the right kind of fuse in it. It is an okay plug otherwise. So these were made, these are Spirit 40F transportables. I've got one behind me, probably. So I'll just push that towards the back. So this is the Spirit 40F, which is a transportable radio. Had aerial you can put on there. Takes batteries. Comes with a dinky mic, and that's what this is. So inside here is what's inside here. So what happened was these didn't sell or something like that, or there was a fire at the warehouse or some kind of, I've forgotten the story now, but they got turned into these base stations. So what you're buying with the Murphy base station is a Spirit 40F walkie-talkie transportable-y thing. So they were never really made to be a base station, and therefore there's this hum problem. But these were made exclusively for great Universal stores who did Kay's catalogue and great Universal, of course, catalogue. Quite a number of different catalogues. John Moore's was one of theirs, where they're part of the Littlewood group. But anyway, mail order catalogues, and at the time, mail order catalogues sold quite a lot of CB stuff, probably until they got the returns. But there you go. So don't expect the best performance in the world from a Murphy base station, which is a walkie-talkie reboxed. It won't take any more screws out. It shouldn't have a socket on the back there, but that's probably for headphones. Right. How are we going to connect this up and show you at the same time? Goodness knows. How are we going to plug this in? By stretching it right across the floor. So yesterday I thought the Eurosonic mic, which was in the box, was probably for the Amstrad set, but then we did the Palmer mic, which didn't work, with a new plug for the Amstrad set. So hopefully this is the right mic. Otherwise we'll use our Spirit mic and then work out what's wrong. So it sits there humming. Got a LED for some bizarre reason instead of a lamp. I'm not going to reverse that. The meters often have failed on these sets, and having the LED there might help in not generating heat and causing the meters to fail. I would say that 4 out of 5 of these have got failed meters. Right, we'll switch picture in picture on, and have I got myself a crib sheet? Let's see. I don't think they've got a problem doing 4 watts. This one's doing 4.2. So I'll just have to pop down a fraction. 4.1. 4.2. So I don't know what current consumption it's drawing. I don't think they're 12. No, you can't plug 12 volts in, so we don't know what the current consumption is. So on low power, it's doing 190 milliwatts. Deviation, wallow, looks to be doing 1.8. Put that there. Test gear's been on about 15 minutes, so we can't really align anything yet, but just see where it is frequency wise. 2779096, that's alright. So in reality, when the gear warms up, it's probably about 05, 79105. So it'll need pulling up a little bit, that shouldn't be a problem. Go back to full power, and the meter on the set reads just over 4. So I'll put 4 plus. So hopefully when we've retuned this to do 4 watts, it'll be a cleaner signal, so it'll be actually a more potent signal than 4.2 watts overall. Meter lamp, all I can do is put LED fitted. Doesn't have public address. The mic works, speaker works because I can hear the hum. Right, so we'll now dial in. This is going to be another thing. How am I going to... I can't take any readings, can I, on receive till I open the lid up and put crocodile clips on the speaker. It's got this 6.3mm socket on the back, but I don't have adapters for 6.3mm. So I have to take the lids off. I'll switch it off. It's one time being vinyl clad. Like all the rest of these, they're about 1982, 1983. Well, let's call it 1982 because they weren't in the first lot of CBs in 81. Yeah, so that goes to an extension speaker socket, and you know, they've got twisted wires, which is okay, but it's right across the power supply. So we can see one distress capacitor there in the power supply. We're going to have to change them all, just as a fighting chance to keep the hum down. So we'll just see what the power supply is running at, and then I better go straight into that. No, we'll still do this. I'm forgetting where I am. We'll go straight into doing this test for the receiver. So put in 2779 096 it was. Get it somewhere near there so that it's fair. I think you can all see what I'm doing. The idea is that if I have the signal generator on the frequency the radio is actually on, rather than what it should be on, and I test the receiver, I'm not giving it any unfairness by having it on the wrong frequency. Right, which one's hot? That one. Should only need the one connection. Yeah, that's reading fine. So Hummer side, and we may not be able to improve it. All I can do is the right thing, and the right thing's to change the capacitors in the power supply. Manufacturing error. And these were a cheap set. They were $69.99. Right, so let's go over to the SINAD meter and just see what we're getting. And 0.71, there's nothing wrong with that. It's not exactly going to be Binatone 5-star standard, but 0.52. And because of the hum, we can't get 20 dB out of it. We can't get more than 14 dB, so I just can't do that. So let's look at squelch. Let's go over to the attenuator. It's what? 100 and no, it's not. It's 560 microvolts for full. So I'd like it to be 100. There's no hard and fast rule on that. And on the receive, and on the threshold setting, set the squelch. Atrocious. It's 4.8 microvolts, so we wouldn't be able to do scratchy corner. We would run out of it, would just not open. So 100 microvolts on the, see what the meter reads. You know what, it's virtually spot on. Like 98, it's spot on. Probably won't be when we've tuned it. Right, so that's gone through it. So the first thing I'm going to have to do is sort this power supply out. So we may get an improvement, we may not get an improvement. So the best I could get was 14 dB SINAD at any signal level. So I'd like to be able to improve that. It would be nice to get 20, but people have tried these sideways on. They've tried all kinds of things, but I'm not polishing something that was never anything other than a real cheap set. Right, so taking those out, replace them with these Nikon ones, like for like, exactly the same voltage and capacity, but higher temperature because they're the ones we buy, and greater life and far higher quality. But will it make any difference? I doubt it. Well, I've still got a whacking great big hum. Let's see whether we can get any more dog biscuits on this receive. Well, you know what? Show you the meter. We have. For what it's worth, we couldn't get beyond 14, could we? So let's just look at the. Come on, change. Thank you. So, if you look now, we've actually got. It's 1.1. So that's been, doesn't affect the range, but it proves it's better. So we're going to put 1.1 in brackets. Good. I'm going to have to probably look all this up now. The other thing is, I want to make sure the power supply is set to something sensible at around 13.2 to 13.8 volts. Take that off there. And where's our output going to be? That red wire. So it's 13.3. That's fine if the set's doing 4 watts. And it was before, so it should be now. It's doing 4.2, so I'd like to see the power supply at 13.8. Because that's industry standard. We'll do 13.7 like that. And then we can, yeah, it's now doing 4.4 watts, you see, so we want to, I just think we've got a fighting chance for a cleaner output with a slightly higher voltage in line with what they're expecting you to do. No idea what all this is. Without getting my notes out, we'll start on tuning the transmitter, which is going to be, hopefully there's no broken cores. The VCO has never been messed with. Are these adjustable for channel, for frequency? Or is it that? I'm probably going to get some circuit out here, but we'll see what we can do from memory. Tell you what, I'm going to tune this on low power. 79102 now we're all warmed up. It's possible that this is frequency. And that's as high as we're going to go, 79106. I'm not even showing you it. 79106. That's within. That's as far as the crystal's going to go. Now, this test set's still warming up, so by the time we're done, it's going to be a little bit higher. So that's fine. It's got a uniden crystal in, so I don't think that's original. Right, let's go for transmit. I'm going to detune. I don't want it doing as much power as it's doing, because I don't want it to kill itself. So where is the green trimming tool? Just going to turn that in a bit to hopefully detune it. It has detuned it, that's good. Take that to 3.5 watts and then we'll start on tuning it. That was not ideal where it was, and neither was that. That was spot on. Detune that one and tune this one. Right, so see where we are on channel 40 and 1. Let's just come, is it down for this one? before. Channel 1. It's a little too high, that. That's 4. It's going to be a compromise, this. It's 4.0 little bit to achieve 3.95 on channel 40. So I think that's probably the best compromise. That's not getting too hot, so that's fair enough. So it's 4.04, which is as far as I dare take it. 4 watts, 3.96. So that's a good compromise. Check there's no sharpness there. No, there isn't. I'm going to have to look up all these variable resistors though. That is either going to be RF power meter or it's going to be low power. So I think we can twiddle that quite happily. So it is the centre of the red zone. It's a VR3 RF meter. I don't know whether it's got a low power preset, so we'll come back to that. Right, we'll go through the receiver, and then I'll have to print off some circuits and remind myself. Right, we'll start with the detector. Let's go over to the oscilloscope. The 100 microvolts on. Make sure delta tune's in the middle. And we'll set the signal generator for what it now is, 277910. I'll say 108 because it's still, things are still warming up. Right, here goes. So that's going to be the detector. That wasn't very good. So go to the SINAD meter now. We'll start with the front end. That's okay. That's okay. tiny bit there. Put a bit more signal on for the IF. That was well out. Now this might be where the squelch wasn't right. That's spot on. Good. Well, that should be quite a bit better. Right, so we'll now go over to the... Well, keep it there. So we've now got 0.42 for 12 dB. 10 dB, 0.37. And for 20, got 0.95. So let's have a look at where squelch is. Squelch to full. A little bit more sensitive, but not how we want it. So just to try and guess the squelch preset, it's either going to be this one or that one. One's going to be the S meter, and the other's going to be squelch. Well, that is the S meter. If you remember, that was spot on before, so we'll get it spot on again, which is there. So VR1 is S meter. So the squelch is going to have to be that one. Surely. No, nothing has happened. It's definitely squelch. So the best we can get is 1.100 is 590 microvolts. So it's actually even stronger than it was before. But let's just see where we are with the sensitivity, because hopefully that's now improved with me doing the IF. Definitely threshold. It's 1.35. So I'd like it to be less than 1, but it needs to be less than 1.5. If you go over 2, 2.5, you're just not going to get scratchy corner. Just try and set it once again, just to be a bit more careful. Definitely threshold. So with careful setting, you can get 0.56. So, yeah. But just normal, set the squelch, I got to 1.35. Let's do a casual one again, we'll do a third time. .75. So, you know, it's got to be carefully set. But it will do it if you're fastidious enough. Is that the right word? Good. Right, so we've covered that and that. So The only preset left is there, which is going to be deviation. So I'll tell you what, we'll plug into the test set. And I'll take a break at that with this throat infection I've got. We're not doing any difficult repairs at the moment, they're all stacking up. Or they can go back, one or the other. Right, other glasses. Whoa, it's a bit low, it's on that one as well, it's about 2. What did we get before? 1.8, so we're about right. Want a bit more on that. Whoa, that's it. So we'll leave it at that, and I'll come back to it in about 90 minutes. You can always know when somebody's talking on one of these, because it's going to hum, isn't it? Okay, so coming back to this, I've decided to change this capacitor as well, also 1000 microfarads on the main board, just in case we can get a little more, less hum. I mean, at the end of the day, I think if that was 2200 microfarads, it would improve matters, but we don't do modifications. So we'll just see how we are up for frequency now. So we'll come back 90 minutes later. So it's going to transmit 2779117. So that's your answer. Good. I've not got any noisy potentiometers. It does smell of nicotine, so it's certainly at one time being in a smoking environment. The final thing I want to do is, having changed that other electrolytic, has it improved our SINAD at all? Wrong meter. There we go. And the answer is it hasn't. So there we go. It just seemed to be the thing to do. Hum wise, let's see whether we can hear ourselves on my walkie-talkie. Let's go to channel 31. Testing 1 2, testing 1 2. And you can hear there's a hum being transmitted. If we go to low power, that probably disappears. And it does. So the circuit was never intended to be a base station. Now, we swapped the screw. We didn't. When we swapped put a new mic plug on the customer's Amstrad set yesterday, when I tried to dismantle his other plug, we took this teeny weeny screw out, and the teeny weeny screw is missing from this plug. So hopefully we can put the teeny weeny screw in this plug, which we can, and that fixes that problem. So I don't know how nice this sounds. Tell you what, we'll just try it on my factory original mic. So look at the deviation from the factory original mic. Helps if we're on the right channel. Wallow, 1 2 1 2 wallow. Showing us 2. It's on 20. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. With that kind of in my mind, we'll go back to his Eurosonic mic. Testing 1 2 3 4 5 5 4 3 2 1. So we've got a situation here where we don't have. I've never made up a standard test mic for Murphy. We've always had either the mic that's come with the set or the factory original one to. Well, they are dinky, aren't they? The factory originals to compare with. I don't really want to go to the expense of making up a Murphy base station mic for no real reason. That's a difficult one, isn't it? Because we do test them always with. I think I will. I think I'll go to that expense just for the video. It's a nice thing to do, isn't it? And then we've got. Then we can do the on-the-air test with the standard replacement mic. And then we can test it with the factory original mic and the one he's provided. So somebody out there be crying out for a Eurosonic original mic. So I'll look up the pinout, if it's even on this list. It's certainly one of the more unusual ones. Well, it is, it's down. It's number 7. Common transmit and audio. So that's something I'll do in a bit, and we'll draw the video to a close. Okay, so I've now done a standard replacement mic, and we'll do the on-the-air test with that. Testing 1 2, testing 1 2. Wallow. You know what? It sounds best with this one. Well, it does on the walkie-talkie anyway. It sounds best with this, then it sounds next best with the factory original. And then finally, this one. I thought it got a crack in that. Anyway, all I need to now do is put the lid on. If we turn the power down to about 3.5 watts, there would of course be less hum as well. That's another point. So we've remember it came doing. It was just slightly over, wasn't it, at 4.2 watts. So between that and the capacitors, it really hasn't helped. So it should be so much better, and we can tell how much better it is just with the SINAD reading, not being able to get 20 dB before. I'm just going to put a couple of screws in for now, because I don't think you want to watch me spend half my life putting screws in. Falling apart, this is. They're self-tappers on these. Or are they? Just get it. Well, that's one on the floor. I'm going to put a new one in for. I'm only doing this so it doesn't fall apart as we do the final bit. going to have to put the top two in, aren't I? It's just going to be the back two I'm not going to put in front of you. Right, so we'll now put it on the roof aerial. I'm so pleased the meter works on this. I'll kind of prop it up, though I'm going to have to put it on an angle so we're not crushing the aerial cable. Let's see what it says about my SWR. Can't even get it to say calibrate. Right, here we go. 19 Roger. This is something on 30. Roger. I don't think they were talking to me. Making sure I've got delta tune in the centre. Good. Right, we'll leave it at that. So, once again, another CBH1500 base station done. And once again, I've told you its origins from the transportable. Thanks for watching.